What you will see now may be a cornerstone in changing the world of material science. Originally, heat treatment was the most common way scientists used to improve the mechanical properties of composites by inducing precipitates in their corresponding matrix. Yet, this method is very expensive in terms of energy consumption, time of accomplishment, and equipment costs. Will nanoparticle addition be able to replace heat treatment? As a proposed methodology, the team implemented a design in order to incorporate aluminum A356 with nanoparticles. The crucible has a U-shaped design, since the curvature in its bottom will encourage the uniform distribution of the particles during mixing and avoid agglomeration. In the middle of a crucible is a piston-like shape that will serve as the pouring element after mixing is done. The heating coil will serve to heat the crucible and keep it at a specified controlled temperature, 750 degrees Celsius, in order to melt the metal and keep it in a liquid state for continuous stirring to occur. The stirrer resembles to a 3-blade stirrer, but with a different design. The cross-section of the blade has an elliptical shape to avoid turbulence during mixing. The shaft of the stirrer is hollow, and through it is inserted the piston, which will serve to close and open the piston-like element in the middle of the crucible, in addition to pumping the molten metal into the mold. The piston is attached to a hydraulic pump that will move it up and down. A bevel gear is mounted on the shaft of the stirrer, which is connected to another bevel gear mounted on the shaft of the motor. The mold is a 2/2 permanent mold made of graphite, which opens and closes to enable extracting the billets. In our case, the billets have a cylindrical shape. The mold is connected to the crucible through a tube, which melting temperature is higher than that of the melt. The cover contains 4 holes, 2 of which are symmetric and permit the injection of nanoparticles through 2 tubes connected to small containers, which house the nanoparticles and argon gas. The 3rd tube through which the argon gas will be introduced is connected to the big tank supply. A 4th hole is present in the center of the cover, through which will pass the stirrer shaft using a journal bearing with solid lubrication to sustain high temperature. Also, the cover serves to separate the melt from outside air, hence minimizing the formation of oxide films on the surface and preventing porosity. The motor will rotate at a specified and controlled velocity, which will allow us to control the steering speed. At the end of its shaft is a bevel gear, connected to another bevel gear mounted on the shaft of the stirrer. This bevel gearbox will allow us to translate the direction of the rotation.